Okay, this is a quick and easy unit. It's in the book. They just really want to get any possible equations that might show a line B. And so we just did the whole, factoring, and we figured out how to factor, all these polynomials. And then you got something that looks like this. X to the fourth minus 4 equals 3x squared. And you think, okay, let's just set it equal to 0. So you have x to the fourth minus 3x squared minus 4 equals 0. And you're like, there's nothing I could do with it. But something in the back of your mind is telling you it looks kind of familiar. And you say, you know what, I know this 3-4 combination. If this were a quadratic, I can easily solve, factor and set equal to 0. And that's the idea. We're going to make a substitution. So instead of x to the fourth x squared, we're going to let b equal x squared. So that means b squared equals x to the fourth. And then we have b squared minus 3b minus 4 equals 0, and you sigh a breath of relief. And we're going to see in these next examples, it's the same structure. If I make a small substitution, I can make it look like a quadratic. So we factor b minus 4 times b plus 1 equals 0. I say that b minus 4 equals 0, or b plus 1 equals 0. So b equals 4, or b equals negative 1, but that's not my, I'm looking for x. I gotta go back into the world of x. So I say that x squared equals 4, so x equals plus or minus 2, or x squared equals negative 1. And we're going to be talking about this, but you did learn that last year it's the square root of negative 1, which is plus or minus I. So so it is a quartic, and there are 4 solutions, and you can say, you know what, I kind of know what this is going to look like graphically. Check it out in Desmos. You should have an intersection at 2 and negative 2, and you should have kind of like a change in direction that doesn't hit the x-axis. Check that out. Next, when we see something like this, you say, well, that's not even a quadratic. That's not even something we're familiar with. But I hate denominators, so what's my secret? Multiply everything by something that will knock everything out of the denominator. So I'm going to multiply everything by x, but you know what? It won't take out the x squared. So I say, if I multiply everything by x squared, then I've got rid of all my denominators. So let's see what we have here. We have x squared minus 7, 7x equals 10. Oh, this should be, I apologize. This should be negative. Actually, you know what? Let's make this positive. No, sorry about that, guys. Sorry. We're going to leave this as negative, right? And we're going to make this 18. I'm sorry. Sorry. So now we have x squared minus 7x minus 18. X squared minus 7x minus 18 equals 0. We have x minus 9. X plus 2 equals 0. We know that x equals 9 or x equals negative 2. Please remember, because there was x values in the denominator, we do have to check to see our values work. Because if x ended up being 0, we'd have to reject that solution. Okay. What's going on here with this exponents? Once again, IB likes this stuff. They used to like this stuff. Maybe they're bringing it back, but it's something we just want to cover for this class. So you look at that and you're like, once again, this 514, I know that. Well, is there a relationship between the 4 and the 2? Yeah. 4 is 2 squared. So I'm going to write 2 squared plus 5 times 2x minus 14. This time, let's write this as 2 to the x squared plus 5 times 2x equals 14. And suddenly, the first example, it makes sense. What substitution am I going to make here? You know what? Let's let b equal 2 to the x. By letting b equal 2 to the x, we have b squared plus 5b minus 14 equals 0. We have b plus 7, b minus 2 equals 0. We have b equals negative 7 or b equals 2, but we don't want b. Let's go back into the world of x. So we have 2 to the x equals negative 7, out. Or we have 2 to the x equals 2, x equals 1. What you're going to see and so the answer is x equals 1. Take a look at the graph in Desmos. See what this is, actually. Last example I'd like to do. Nope, I think I have everything I want to do. You can try this on your own. No, that's good. Okay.